Good day, everybody. Welcome to Anatomy Physiology. For this lecture here, I'm going to give you a mini lecture, kind of go overview of how the kidney works. So when you look at the kidney and think about the kidney, it basically has the major function of taking blood that has a lot of stuff inside. Some of them are good stuff, some of them are bad stuff. So this includes things like nutrition and also waste product inside of the blood. And once it gets to the kidney has a function of separate between the good stuff, the nutrition, and the bad stuff, the waste product, and then separate into the urine, right? That's how you eliminate the waste product, and all the good stuff, the nutrition, the red blood cell, white blood cell, maintain and stay inside of the venous system. Come back to the heart as the renal vein. So for this lecture here, it's gonna be mini lecture, meaning there's a lot of stuff here that I'm gonna omit, I'm gonna skip it, so that we have kind of look at the overview of the function of the kidney, so that when you go back and go through the actual lecture and the big lecture that's about an hour long and overall, and that basically you get a better idea. So let's start off with the artery itself, mainly the renal artery. So for this lecture here, by the way, it's just gonna be me writing out all the different area of the kidney. So just bear with me as I kind of write it out for you. So here's the renal artery. I'm gonna short the artery as A and the dots, but you understand that this is the artery with the blood going inside. This renal artery here just does not appear out of nowhere. It actually came from somewhere, and that somewhere is descending aorta, right? So I got a descending aorta, and as the blood coming down, some of the blood will continue forward and feed into the rest of the body, your lower extremity, your legs, your foot, and whatnot. So, and we'll leave those alone, but we're gonna continue with the blood that kind of move forward going into the aorta to the kidney. So, if you continue with the renal artery and continue forward, and I'm gonna kind of write it out all the blood vessel, but I'm gonna kind of give you a rundown that the next step. In addition of the renal artery, what branch off from the renal artery is your segmental. So segmental artery, right? So it's a smaller branch of it, and then we'll continue forward and into the interlobar. So once it gets to the interlobar, that's how they get closer and closer. We are right at the medullary layer of the kidney at this point. Once it continue forward, it will continue upward into the area where it will continue and continue at the curvature of the renal pyramid, and that will become arcuate artery. Once it becomes the arcuate artery, it will continue forward into the cortex part, and that's where they become the cortical core. I can write well on this one here, so I got a cortical radiated artery, and as it continue forward as the cortical radiated artery, it will basically continue into the capillary layer, and before it gets to the capillary layer, it's actually going to become afferent arterial, right? Because it's arterial comes before the capillary. But for the kidney, as it continue forward, it's actually going to become glomerular capillary, and this glomerular capillary is what hang out inside of the renal capsule. So once it gets to this glomerular capillary right here, gonna kind of come right back and start showing you what it means when the blood getting into the afferent arterial. So afferent arterial. So now we got the blood vessel. As the blood vessel, this guy's right here, continue forward into the capillary. So the capillary, you're gonna make a big drawing. So I'm gonna move my monitor, keep going forward right here. So as I keep continue going forward, I am gonna have a big area right here that will become my glomerulus, and this glomerulus is filled with lots and lots and lots and lots of fenested capillary. You remember the fenested capillary? If you want to learn more the details, go back to the big lecture. So, all right, once the blood getting into the glomerulus, it got to go through the filter. That's the whole function of the kidney. It has to filter the blood. So they got 3 layers of the filter. Number 1, you got the fenestrated capillary that we talked about earlier. Layer number 2, you have the basement membrane, the lamina densa, that providing lots and lots of the negative charge. This negative charge will repel all the plasma protein that has the negative charge and everything else that negative charge, and keep it inside of the blood vessels. Beyond that, you also have the podocyte. So I'm gonna go ahead and change the color here for you to something a little bit different, so you get the idea that you got a podocyte hang out on the outside, and this podocyte here providing another layer of filtration, so that only very small molecule can pass through. What are some examples of those smaller molecules that can pass through the podocyte and further into the area? So, and I'm gonna go ahead and make a adjustment on this one here, so that I can draw a additional passageway forward. So I got the renal capsule here on the outside, but beyond that, you got your renal tubula. So that's your renal tubula, particularly the proximal section. So you got a proximal section. I'm not gonna write the whole thing. So, and coming back to this one real quick. Now, all the content that comes out at this point that comes out is going to be very small, very tiny, highly selective molecule. So what are some examples of the stuff? These are going to be things like glucose, going to be electrolytes, things like sodium, potassium, chloride. Some might be a little, one of those smaller amino acid that you might want to keep that later, but we'll come back to those stuff. But that's the content that goes into the renal tubules. This area here, on that at this point, these fluid that comes out, we call it filtrate, and these filtrate here will continue forward and later will becomes other content like your urine. So when you continue forward, and I'm gonna keep on drawing for you, kind of give you a big picture of what's happening as it continue forward, that it will continue and becomes, so I'm gonna make it smaller so that you can see a big picture of where we are so far. All right, and as you continue forward, this thing will keep going, take a deep dive, and gonna keep it further, actually gonna keep on going. So this is gonna be like one time and a slide here, so that is gonna keep on going, and you're gonna turn into a loops. So this loops right here as it coming back. So at this point here, this is the proximal part, particularly the thick descending part of the renal tubule. You're gonna have loops of Henry or renal loops. And why do they call renal loops? Because it's literally looping around as they're coming back up. So your filtrate, oops, that's too big. I'm gonna switch back to this one here. I'm gonna continue with the same color. That as the filtrate continue forward, it's basically gonna keep going and keep going until it gets to the distal part. And a distal part here, guess what we name him? We call these area here distal convolute tubule. So it's part of the renal tubule as well. But there's a specific catch, there's a small catch on this one, that as you continue forward, there are certain section of the distal convolute tubule that kind of comes along, kind of take a little section, little detour, in order to come very close to your glomerulus and also glomerular capsule. So by the way, that's the capsule. And remember, the capsule and glomerulus is what makes up the renal corpuscle. So when you continue forward, I got the distal convolute tubule that keep on going, and then it's gonna continue forward. But this part at this point right here, this will becomes your collecting ducts. So that's your collecting tubes or collecting duct. So, and as it continue forward, this content right here, now I'm gonna switch back to the other color. So now your filtrate will keep continue. So follow that. It will become later on urine. So, and once it become urine, then this collecting duct, this guy's right here, will keep continue forward. So I'm gonna switch back to my drawing, and this collecting duct will continue forward, becomes other part of the kidney, particularly the area that we call minor calyces, which later will becomes major calyces. And once it becomes the major calyces, it will continue forward into the renal pelvic. So I'm gonna loop it right back into the renal pelvic. And remember, by the time they get to this major and minor calyces and renal pelvic, you are right at the very end. You got big tubula that collecting millions and millions of this collecting duct right here that converge together into bigger and bigger tubes into the renal pelvic and eventually into your ureter. And once they continue forward in the ureter, it will keep on going. Oh, now I lost it. Sorry, give me 1 second. Come right back. Here we go. So it will continue forward, and becomes the bladder. So once it goes into the bladder, you store the urine in the bladder until you're ready to urinate. So that's the first section of what happened after the filtrate that comes out from the kidney. So now we're gonna come back to the kidney real quick and give you what the heck is going on with this area here. So I'm gonna give you a big picture so far and see where we're going. So for right now, you have this area here, that what we call renal corpuscle, which make up of the two sections, including your glomerulus in the middle and the glomerular capsule on the outside. So that outside area here, that's the capsule. In addition of this renal capsule, you also have this big overall area right here. This is what we call nephron. And the nephron comes into two compartments. One is what we just talked about earlier, the renal corpuscle. The other section is what we call renal tubule. This whole area here, the renal tubule, the other latter part of the nephron. Of course, there's two different types of nephron depending on whether you have this part right here, the loops of Henry, that is hang out more in the cortex of the kidney, or take a deeper dive into the medulla layer of the kidney. So that's how we have the cortical nephron versus the juxtamedullary nephron. So that's why we got two different types. So that's go back into the lecture if you have no idea what that is. So now that you get to see the big picture, you know what happened to the urine, now let's continue forward with a different section. So I left you with this part right here, the afferents arteriole, the blood getting into the glomerulus. Now let's have a look at what happened when it comes out. Now gonna change the color to something else that you can see the contrast better than all the red color that I show it to you here. So we're gonna zoom in into the area of your glomerulus. So you got blood that goes inside. You want to keep blood inside of the blood vessel, and the blood vessel will keep continue forward as it comes out. The blood that comes out on the other side of this glomerular capsule is the area right here, and this is what we call efferents arteriole. So, and I'm gonna come back right here, and I'm gonna move it a little bit to the side so I can write on this one that this is what we call efferents arteriole. And this efferents arteriole, this guy's right here, we got blood that contained inside as it comes out from the glomerulus capillary. So these are the stuff that you want to keep inside of your blood, inside of your body. So this includes things like red blood cell, white blood cell, or the plasma protein, all the good stuff that you want to keep in. So now the problem with this one is the content inside of the filtrate, all the stuff that you filter out, these guys right here that we mentioned earlier, that this include glucose, some of the electrolyte, sodium, potassium, chloride, some of the could be acid, could be some of the bicarb. Those are some of the stuff that you can still use. You can keep some of those stuff along with water, because remember, filtrate is water. Your urine is 99% water. If you're in a condition where you are a little bit dehydrated, you want to conserve your water in your body, well, you have a way to reclaim some of those material with the use of this guy, your efferents arteriole. So if you continue and see what's going on with the efferents arteriole. So what I'm gonna show it to you is we're gonna continue forward and continue with that efferents arteriole. And if you follow it through, what's gonna happen is this efferents arteriole will continue and coming down and actually come very, very close, almost next to this guy. So I'm gonna clean up some stuff right here. Actually, give me 1 second to take some of that stuff so you can see the efferents arteriole better. All right, that's a little bit better. Cool. So continue. As your efferents continue forward, it will come very close, literally right next to your loops of Henry, your proximal convolute tubule, and also continue right next to your distal convolute tubule as well. When this occurs, when you have these tubes that are right next to your renal tubule, this right here, this whole thing that you see here that I'm keep on drawing, is what we call peritubular capillary. So peritubular capillary. And the name tells you exactly why they name it that way, because peri means surround, tubular, well, tubes, right? It got the tubes, and it's capillary. And the reason they do so is because all the filtrate, so I'm going to change the color to the one that we saw earlier. So I'm going to switch to this one, that all the content that continue forward, including glucose, water, electrolyte, you have ability to reclaim that and kind of send it back. So I'm gonna actually draw the arrow a little bit different, so you can reclaim it into your peritubular capillary. And if you allow this peritubular capillary and follow it forward, so now we got the peritubular capillary right here. Gonna keep on drawing, and now we're gonna come back up and continue forward. This will later becomes, oops, sorry, and come right back. Uh-oh, what's going on? What happened? All right, here we go. Now we're back. If you keep on going, this will later becomes your area called cortical radiated vein. So I'm gonna go ahead and write it out for you as we take a turn. It's gonna become, let me rewrite that, cortical radiated vein. And as you continue forward, so I'm not going to draw the blood vessel anymore. I'm going to show you as the arrow. As you continue forward, it will becomes, and you can kind of take a guess where I'm going with this, that it's going to become arcuate vein. And as it becomes the arcuate vein, it will continue forward as the interlobar vein. And as become the interlobal vein, it will skip that segmental artery. We do not have segmental vein, so we're going to skip that. Unlike the artery, we have the segmental artery. We do not have the segmental vein. It will continue as your renal vein. And as become the renal vein, it will basically converge and continue into your big blood vessel, which is your inferior vena cava. And as it continues as inferior vena cava, it will continue back to the heart and then the rest of the circulation. So you get the idea where it's going. All right, now coming right back to this area right here that we talked about earlier, that you're able to reclaim some of the stuff, right. So this area here giving you ability to reclaim all the good stuff, the glucose, the water, the electrolyte. If you run a little bit low on sodium, you can reclaim that in this area. If you're running low a little bit of water, you can reclaim some of that in this area and also in the collecting duct, this area as well. So that's a hormone that's specifically made for that. It's called the antidiuretic hormone, but we'll see that later. So, all right. As you continue forward, you can also do the opposite. You can have the content inside a renal tubula that if you want to get rid of them, well, just dump them into the renal tubule. And as you dump them into a renal tubule, you're basically going to eliminate them. So if you continue and dump the stuff here, just follow the tubes and it will basically keep on going until it becomes the urine and you eliminate them later. So this is the area of the big picture of how the kidney works, how the kidney separate the blood going into the kidney and separate them into the urine or coming back as the renal vein. So the blood, basically some of the good stuff continue backward. And this blood right here, of course, is going to be cleaner blood in comparison to the blood that going in. So we'll continue. So we're going to continue forward a little bit, going into talking a little bit about the cell. So I'm not going to go into all the nitty-gritty details about the cell. So let's use green color. So we have the area called juxtaglomerular apparatus, and this refer to the group of cells. Some of them hang out right here at the area, the afferents arteriole. This group of cell here, we call this group of cell JG cell. And this JG cell right here has another name called granular cells. Depending on which textbook you open, they can use it interchangeably. But for us, I'm going to make sure that you understand what it is, so I'm going to stick to the JG cell, the juxtaglomerular cell. So the juxtaglomerular cell is a specialized type of cell. It's a type of smooth muscle that able to constrict the blood vessel or the dilate blood vessel. And depending on how the diameter, whether it's constricting or dilating, that's how you manipulate the amount of this guy, the amount of filtrate that goes into your rest of your urinary systems. If you open this up, dilate it, then more stuff gonna comes out. If you constrict it, then less stuff gonna comes out. Very simple, right? Your JG cell, this guy's here, also have another function of having ability to secrete enzyme called renin. And this renin here is part of that renin-angiotensin systems, and your body, your kidney, will only release the renin enzyme when your body experiencing dehydration. Your body wanna reclaim or conserve water. So renin, if you wanna remember the function of renin reserve or conserve water. So reserve or conserve H2O. So I kind of give it simple. So if you kind of want to associate that, give you easier way to memorize them. Because once the renin is secreted, it will go and find a substance called angiotensinogen. So angiotensinogen is the zymogen. It will turn itself into angiotensin 1 and eventually will find itself into angiotensin 2 with the help of a little enzyme called angiotensin converting enzyme, whereas your renin, this guy's right here, works on this step right here. So, all right, two different enzymes. At the end, you got this guy right here, angiotensin 2, which have a major function of couple things. Number one, it has ability to help secrete the aldosterone, and the aldosterone has a function of helping their kidney to reclaim this part right here, to reclaim a lot of salt, sodium. With sodium being reclaimed, the water will follow, and once the water follow, now you basically keeping water in your renal system, in your venous systems, and of course you just follow the peritubular capillary, continue forward as the water get into the renal vein. The angiotensin 2 also is a powerful vasoconstrictor, and that of course constrict the blood vessel throughout the body, help you maintain the blood pressure. So the next thing is you also got a couple more cell in this area. So you have your other cell. So let's use a different color. Let's say I'm gonna use this color right here in yellow. So the yellow color right here represent the mesangial cell. The mesangial cell comes in two different groups. So you got one, not two different groups, two different types. You got one type that is intracapsular. That's why I'm drawing them inside here. Intracapsular mesangial cell. And this mesangial cell has ability to help clean up. So I'm gonna clear out some of the stuff here. So it helps clean up. So it has a mesangial cell. Help clean up your filter. Remember, you got three layers of the filter. Of course, you cannot keep using filter on and forever, right? So the mesangial cell help keep it clean, clear out some of the bacteria, clear out some of the big plasma protein that got clogged or and blocking the filtrate. Just like air filter at your house, you cannot keep on using air purifier without changing the filter, right? So it's not forever. Same thing, your mesangial cell help keep your filter in your glomerulus nice and clean. That's number one. Number two, you also have a second type of the mesangial cell. So I'm gonna change the color to something similar to the yellow color. So let's use orange color. So the second type of the mesangial cell, this guy's right here, is called extracapsular mesangial cell. It hang out kind of off to the side. So this extracapsular mesangial cell, I'm gonna continue upward. So I'm gonna move up. Here we go. And too far. So I'm gonna have this guys right here. You got the extracapsular mesangial cell. This guys here is a little bit of mystery because a lot of people doesn't quite sure the function of this guy. So gonna hold on to that part right there. We'll come right back to this guy. I'm gonna introduce you to the third cell. So this third cell, I'm running out of the color. What color would you guys like? Let's use purple. How about that? So I got a purple right here. A little bit too close. Let me get a darker purple and this one. So, all right, got a darker purple. I'm gonna draw it on right here, where you have this guys right here on the distal convolute tubule. This distal convolute tubule has a special group of cells that hang out right here on the other side. And notice the location, that the location of this group of cells just happen to be quite really close to this JG cell right here. It doesn't want to hang out right here on the further side. It doesn't want to hang out right here in the collecting duct either. It just happened to be right in this particular part of the distal convolute tubule, very close in proximity to that JG cell. These guys right here is called macula densa cell. And this macula densa cell, this group of cell here, works kind of like a quality control type of cell. Why is it called a quality control type of cell? Because these guys here have ability to monitor the osmolarity of the filtrate of the content as it passes through your distal convolute tubule and before it continue into the collecting duct. That if you have the filtrate that is a little bit concentrated, a little bit too salty, and this tells that the fluid, the content, the flow of the filtrate that goes into the distal convolute tubules going a little bit too fast. It's going a little bit too fast that your cell in the lower part of your renal tubule, like all the cell right here in the descending the loops of Henry and the ascending part of the renal tubule, does not have enough time for them to kind of pick up all the good stuff, and put it back into the body. So your macula densa, these guys right here, tells your JG cell that, hey, you need to slow down the amount of the GFR a little bit. Slow down the amount of this filtrate so that the cell in this area have more time to do the reabsorptions. You with me so far? Cool. And if you continue with the opposite scenario, say if you have too little of the content in this area and the filtrate that comes right in this area where you have the macula densa will be hypoosmotic filtrate, meaning you got the urine that's a little bit too dilute. There's too much water in this area, meaning the flow in this area here go a little bit too slow. The flow that comes here going a little bit too slow. You got pick up a lot of stuff here, a lot of salt into your peritubular capillary. So what I'm gonna do, the macula densa will tell the JG cell that, hey, you need to let the flow go faster, and the only way to allow the GFR to increase so that the filtrate go faster is to dilate the blood vessel, to dilate the JG cell. And with the dilation of the afferents arteriole, of course, now you're gonna have more stuff coming in, right? More stuff coming in, then more GFR. Now you basically have fixed the problem at the very end. So cool. All right, continue with the quick point on the pressure real quick. So I'm getting into, like, it's already about half an hour, so I'm gonna kind of closing this up. So I'm gonna clean out some of the area here, and we're because I don't want this to be another lecture basically. All right, so in this area here where you have the JG cell, so I'm gonna clean out some of the mesangial, that the fluid, I'm gonna change that to, what's the color should I use now? Let's go with black color. So all right, the pressure that coming in to the kidney is about 55 millimeter mercury, and this 55 millimeter mercury right here gonna destroy your glomerulus. Your glomerulus is too delicate to handle that. So your JG cell, these guys here, play a important role of adjust that to a certain degree. But once it gets into the glomerulus, now you got a couple more of the pressure that kind of go against this 55 millimeter mercury, which is, by the way, a hydrostatic pressure. Just by the sheer fact the water, the blood, it basically carry all the pressure into the kidney. But once it gets to the glomerulus capsule and the glomerulus capillary, now the capillary will have to fight with another pressure, the osmotic pressure, or the oncotic pressure, and that account for about 30 millimeter mercury. And what is this 30 millimeter mercury? The oncotic pressure is due to all the blood and all the content right here in the efferents arteriole, like all the stuff that you keep inside of the blood, all the good stuff, those will account for a lot of your 30 millimeter mercury. This include albumin, all the other plasma protein hang out on the inside. So that's one. Number two, you also have the fluid in the renal corpuscle, in the area and all the filtrate that already comes out in this area here that fill out the surrounding area in the capsule, those fluid will also have its own hydrostatic pressure as well. Just by the sheer fact of having the fluid itself, you will have the hydrostatic pressure. So and this area here, this pressure will account for the rest of the area here. So if I do my math correctly, so that about like 15, so that would be minus, so that, and I said minus because it go against this guy, right. So and with all of them together, I don't think I got it right. So hold on, I'm trying to get to the 10. So so the 10, I need 45. Yeah, it's 15. Hold on. So I got 45 minus, yeah, it's 15. So, and 45, wait, I will have 10. Yeah, perfect. All right. And sorry, I got a brain fart. So minus 15 millimeter mercury. That's the hydrostatic pressure inside of the renal capsule itself. All right. And when you subtract everything, 55 minus 30, and that would get you 25. And after you got a 25, you minus also 15 one more time. So that would leave you with a net of 10 millimeter mercury. And this 10 millimeter mercury, this guy's right here, is what drive, that's the pressure that drive this filtrate right here and keep on going into the rest of the renal tubule. So that's the overall view. So I got gonna come back and show you kind of big picture of what we drew so far, starting from the blood vessel, going into the kidney, what happened to the kidney here that helps separate the content into the blood and keep sent back to the heart, or the content with the waste product and all the stuff that you want to eliminate and continue forward into your minor calyces, major calyces, renal pelvic, ureter, eventually to the bladder, and eventually outside of your body. All right, so that's the overall look at the introduction to the urinary system. Once we come back, we're going to focus more on this section right here on the renal tubule. How is this mechanism, this mechanic works right here. So, all right, that's all I have for today. Thank you for listening. I'll see you next time.